Okay, so Newton's third law deals with what we call momentum. And momentum has the formula of what? If anybody can remember that off the top of their head. Or use the formula sheet if you have it. It has some weird.
Momentum equals mass times velocity.
Yeah, and we call momentum, this looks like a P there, mass times V for velocity. So again, just a simple three variable equation that we have, and so P, M, and V. Like I said, I always break it down so we can identify what variable is going where and then what we need to solve for. So on problem number 1, it says a pitcher in a professional baseball game throws a fastball, giving the baseball's momentum of 5.83 kilograms meter per second, and that the baseball has a mass of 0.145 kilogram. We want to know what is its speed. So again, we go through this and we say to ourselves, okay, momentum, is that given or do we need to solve for it? It's given, and what is it, Tyler, there?
5.83.
5.83, and momentum, I will tell you, has kind of an odd unit. It is kilograms, and that dot that you see on the page is the same thing as a multiplication sign. So you can put a dot or you can put a multiplication sign, and then that is times meters per second, and that second is all on bottom. So again, kind of a weird unit, and it's all because of the combination of what factors into it. So then the mass of that baseball is given in what?
0.145 kilograms.
There we go, 0.145 kilograms. And just to double check, it may throw you off here, you may have to look up conversion. Our units of mass have to be in kilograms. They are, so we're good to go. And then do we know the velocity of this? No, so that becomes our big question mark. From here, we just throw it back into the equation. So we're gonna go with 5.83 kilograms meter per second equals 0.145 kilograms times our V. V is attached via multiplication, so how do we get rid of that? Divide by what it's attached. So we're going to divide by 0.145 kg on each side. So all you need to do in your calculator is take 5.83 divided by 0.145. And is anybody still trying to calculate? What do we get for answer here?
40.2 meters per second.
40.2?
Yep.
Perfect. Meters per second is that V for velocity. Moving pretty quick. So, questions on how to solve for V for velocity when we're talking about momentum or utilizing the momentum formula. Okay, like I said, I just want to go over, make sure we have a honed in portion on how to solve for each of the variables. I hope by this point the math kind of starts to look familiar. You know when to divide, know when to multiply, and things of that nature. That's the biggest portion here. So let's go over number 3. It's complex because you put a lot of jazz in the front of it here, a lot of knowledge here. So it said the World Solar Challenge in 1987 was the first car race in which all vehicles were solar powered. Fantastic. The winner was the GM Sanyder car, which had a mass of 177.4 kilograms, not counting the driver's mass. Assume the driver had a mass of 61.5 kilograms. So the total momentum of this car was 4.416 times 10 to the third kilogram meter per second. We want to know, we already solved for speed. Let's go ahead and go down to number 4. Skip what I said here. So, have a lot of jazz again. Lightest pilot-driven airplane was the Baby Bird. Suppose the Baby Bird moves along without a pilot at a speed of 88 kilometers per hour. Under these circumstances, the momentum of the empty plane would be 2,790 kilograms meter per second. What is the mass? Okay, so that's my fault on that one. We start out here, and the momentum. Is the momentum given in this problem? What is it?
2,790.
And again, it's a goofy unit. It's kilograms meter per second. And then the mass. Does anywhere in there say something about the mass? No. So that mass becomes our big question mark. And then how fast was that plane moving?
88 kilometers per hour.
88 kilometers per hour, right? Okay. Now, and here's where we have to always be careful. Kilometers, I'm going to write it differently. Kilometers per hour, HR. Is that the same unit as meters per second? No, so we have to do a conversion. And you could Google it, but this is a real simple conversion. We want to go from kilometers to meters. So remember, whenever we go through this process, we always think about units first, and the thing to keep in mind is diagonals always cancel. So that means, without putting any numbers, we got to put the same unit diagonal from each other. That means kilometers are on bottom for this conversion. What we want to get to is on top, meters. Now, again, you can look this up, but there is 1,000 meters for every 1 kilometer. So right there, we have converted it, and you could calculate that out, but what I would do is I would go one step further, because we got to get rid of hours. So hours, again, diagonals need to cross cancel, or diagonals need to cancel out. So this time the diagonal is actually upper right to lower left. So that means the unit of hours needs to be on bottom. Now we can go straight from hours to seconds. And so we want seconds on bottom, so we can put that there. Now, this is something, again, I don't expect you to know off the top of your head, but does anybody know how many seconds are in an hour?
3,600.
There you go, perfect. Seen this before. 1 hour has 3,600 seconds. And that saves you a lot of time from going to minutes and things of that nature. So when we make this conversion for velocity in the calculator, what I would do is I'd take 88 times 1,000 times 1, and then I would divide it in parentheses everything on bottom. So in parentheses you'd have 1 times 3,600, or because it's just 1 times 3,600, you could divide what you get on top by 3,600. So what do we get for our velocity per heat?
24.4 meters per second.
Okay, perfect. 24.4 meters per second. So you will see this type of conversion quite a bit, and it's because, think common cars. Cars, obviously, we're not in any other country in the world, but any other country in the world expresses their velocity of the cars as kilometers per hour. In the science application, meters per second is a lot more useful. Alright, so plug this stuff back in, and so we end up with 2,790 kg meters per second equals our mass, big N because we don't know it, times 24.4 meters per second. Again, very similar to what we had. How do we get M by itself this time? Divide by 24.4. So now in your calculators, all you need to do is take 2,790 divided by 24.4, and is anybody still calculating? What do we get when we do this calculation?
114.34.
Yep, and I'm gonna just round that to 114. And because we're solving for mass, what would our units be? kg, kilograms. Okay, so like I said, the biggest challenge is probably gonna be velocity. Occasionally we'll throw a mass conversion in there. But is there any questions on this type of problem? Okay, so let's do number 7 because that calculates the final variable we haven't gone over. Then I'll give you some time. We got a little bit of time here. I don't plan for you to have these done until tomorrow, so don't worry too much on trying to pound through these things here. So great, we have a train here, 16 aluminum cars. It has a combined mass of 7.1 times 10 to the 5th kilograms. At the top speed, it reaches 270 kilometers per hour. We want to know the momentum of one of these trains at its top speed. So, we start out here with the momentum. Do we know the momentum, or is that what we're going to solve? Yeah, that's our big question mark. Our mass, what is the mass given in kilograms?
7.1 10 to the 5th.
7.1 times 10 to the 5th, and that is in kg. So we're good there. And then our velocity, how fast is that train moving? 270 kilometers per hour. So again, to correctly do this, we have to have it not in kilometers per hour, but in meters per seconds. So we just did this one. So again, diagonal units always cancel. So km would be on bottom. We want to get to meters. Remember, there's 1,000 meters in 1 kilometer. And then the same thing with the seconds conversion. We have hours that need to cancel on top. Seconds, we need it on bottom. 1 hour, you told me had 3,600 seconds. So if we do that calculation, what do we get as the velocity here? What's that? 75 meters per second. And I'm going to keep it as 75.0 meters per second. And so now we can plug this in to find the momentum. So the momentum here, our P, we have 7.1 times 10 to the 5th kilograms. And I'm going to talk about this scientific notation because we have not gone over it. But we multiply that by 75.0 meters per second. Now, for scientific notation, you can plug it into your calculator, but if you plug it into your calculator and it looks exactly like this number, very, very important that you put a set of parentheses around that particular scientific notation. Then, once you do that, you can multiply it by that 75 meters per second. So, what do we get here with the train's momentum.
5.325 times 10 to the 7th.
Yep. And I am going to round that to 3 digits here, so our momentum here, would just be 5.33 times 10 to the 7th, Tyler.
Yep.
Okay, and again, it has a goofy unit of kilogram meter per second. Okay, now, I realized, cause I plugged it into my calculator, and I got a bunch of zeros. Does anybody have a bunch of zeros and things of that nature? Okay, let me show you how to go from scientific to English, and it's a little bit different on each calculator. So, this right here is our, same, almost same number on this one, just
Thanks.
on that one, that was, you had 701, just 701 times 10 to the,
Okay,
the-
gosh, we have.
75, so, yeah, that's how we got that answer, and then the only thing that we need to do here is. It's a little bit different on each calculator, so. Oh, okay, this one's nice, it has a mode, and then you see how there's a, what we call SCI.
Yep.
We click enter, and then we click out of that, and we click enter again,
Okay.
that's where we get
Okay.
it. Now, if you go back to math class or anything like that, just make sure you're back in
Yep.
normal there.
Alright.
So, yep,
Thank
Or-
you.
whoop, whoop.
Thank you.
It showed me.
Showed, okay.
Yeah.
Good, yeah, like I said, each function of the calculators are a little bit different, so don't worry too much about it. Alright, so I'm gonna give you time tomorrow, I realize class time's about out anyways, and so, any final questions today? Just hang on to that worksheet, I will give you time tomorrow in class.